Hello, and welcome to today's lesson, which will be a continuation of my last lesson on basic combinatorics. So none of what I'm about to show here is actually needed for GCSE, but you might find it interesting. Feel free to watch. If not, my next video will be on powers and roots, so look out for that. So, to start with, I'm aware that I kind of bandied about a couple of terms towards the end of last lesson, which were permutation and combination. And I just want to shore up what they are and explain there. So permutations, as I've got here, is the number of ways to arrange or select elements from a set given that the order of identical elements is important. And combination, as I've got down here, is the number of ways to arrange or select elements from a set given that the order of identical elements is not important. So the difference here is whether the order is important or is not important, basically. And to give an example of that, let's say you had an Olympics race, 100 meters sprint. And obviously, if it's the final, then you get the top three. You've got a gold medalist, a silver medalist, and a bronze medalist. And obviously, there the order matters. So if you had your top three places, the order in which those places basically were taken has an effect. However, if it's just a qualifying race, i.e. the top three finishers go through to the next round, but you don't get a better chance if you win than if you come third, that would be a combination. So it's a little bit wordy, but let me take you through this example. So let's say our three runners that come in the top three are Alice, Bob, and Charlie. Now, Alice, Bob, and Charlie, if this is a qualifier, can come in any order they like. But if this is the final and we want to consider the permutations, these top three finishers, well, how many are there? Well, we've already seen this before. We know that it's just 3 factorial, which I will write out quickly for you here. CAB and CBA. So there are 6 possible permutations. So we can see these 6 possible permutations all contain 1A, 1B and 1C. So although there are 6 permutations, these all amount to one combination. And what this matters, this is going a little bit into selection, which I'll probably devote another video to. But if you wanted to pick 3 elements from a set, like your set of 8, if you wanted to find the number of ways of 3 of those 8 runners coming top 3, if it was the final, these would be counted as 6 different combinations or 6 different permutations, along with all of the other combinations that doesn't include one or all of these people. But if it was just a qualifier, all 6 of these permutations are the same combination. So it doesn't matter whether Alice comes first or third, Bob wins or comes second, etc., because the result is the same. So obviously permutations where the order matters, things like races, or anything where there's a first, a second, a third, and combinations is where it's just the same thing repeated. So at the end of last video, I set you 3 numbers that I wanted the number of combinations to. They were 9, 12 and 11. And I just want to go back over that, shore it up, make it a bit clearer. Just make sure no one's in any doubt. So here I've got 9. And as you can see, I've written 1N in red and 1N in blue. And at the end of last lesson, I told you that there were 12 combinations of the letters in 9. Before I continue, first of all, it's worth noting that the number of permutations, i.e. where the order matters, is 24. Alright, a C there and a P there. And as I said, to get from the number of permutations to the number of combinations, we divided by 2 factorial because there are 2 repeated elements. And I just wanted to show you why that is. So here I've got a list of all 24 permutations. I've got it in 2 columns of 12. One column on the left here always has the red N as being the N further to the left, and the blue n is the one further to the right. And in the right hand column it's the other way around. The blue is always to the left of the red n. And what you can see is that on any row of this table, we've got exactly the same combination. This top row is EINN and EINN. It's exactly the same combination of letters. The only difference is whether the red N is before or after the blue N. And that continues all the way down the table. And this is the case because wherever the N's go, we are going to have the number of permutations of their arrangement. So because there are 2 N's, we get 2 factorial. When we looked at 11 last time, because there are 3 E's, there are 6 possible orders of those E's. So the first E could be the furthest left, or the second E could be the furthest left, or the third E could be the furthest left in the eventual permutation. And once you factor those different permutations of the E's in, you get down to the number of combinations. So just to reiterate that, if you have 3 E's in 11, if I can get technology to cooperate. So you can have the red E first. I'm just going to go through and do the green E's quickly. Now, the red E first, followed by the blue E, followed by the green E. I say followed, if you read the word from left to right, this would be the order you'd encounter them. And last load of red E's. And you can see, as you'd expect, I've missed a blue E there. There are 6 or 3 factorial combinations, not combinations, permutations. See, these words are confusing and they're basically the same thing, and in normal English they pretty much are interchangeable. But in maths, that difference between whether order is or isn't important does matter, particularly if you then go into selection problems. But yes, so here we've got the 6 permutations of the E's, and then you could, for every combination of the letters of 11, you would have this many permutations of that one combination. Oh, I've got some random lines. That's always fun. So, the general rule is, if you have a set with a repeated element, something like 9, where you've got the 2 N's, you work out the number of permutations of that set, so in this case 4 factorial, and divide that by the number of permutations of the repeated elements. In this case 2, so 2 factorial. And that gets you the number of combinations. So I should have said that at the start. That is if you want the number of combinations of the arrangement of elements in a set, in this case letters in the word 9. If you have a word with multiple different repeated elements, something like, level. Here we've got the 2 L's and the 2 E's. So what we have to do is, first of all, we work out the number of permutations, 5 factorial. And then we know that there are 2 factorial or 2 permutations of the L's. But there are also 2 factorial permutations of the E's. So for every combination, every combination of level, let's say we had V, L, L, E, E, there are 2 options for the arrangements of the L's and 2 options for the arrangements of the E's. So what that actually amounts to is 4 possible arrangements. We could have, let's say, L1, L2, E1, E2, have L2, L1. Oh, I rubbed out my L there. And likewise, we can swap the E's. We can have E2, E1, and then if we swap the L's again. 4 different arrangements, or 4 different permutations. And we get that 4 by doing 2 factorial times 2 factorial. I've got random stuff that I forgot to write out. Yeah, so if you have more than one repeated element and the repeated elements are different, you just divide by the factorial for each. So 5 factorial over 2 factorial times 2 factorial here equals 30. You can put that into your calculator. For shorthand, I will just write these sorts of things as 5 factorial over 2 factorial, omitting the multiplication sign in the middle. This is quite common. You'll see this a lot as you progress through your mathematics career, I hope. So yeah, so if there's not a multiplication sign on the bottom, just assume they're multiplied because they are supposed to be. So yeah. So your turn now. Work out the number of, first of all, the number of permutations and then the number of combinations of letters in the word banana. So feel free to pause the video to give yourself more time. And hopefully once you're done, you would get that, first of all, the number of permutations is just 6 factorial, which is 720. The number of combinations is the number of permutations divided by the number of permutations of the 3 A's, 3 factorial, and then that answer divided by the number of permutations of the 2 N's. So we've got to stick a 2 factorial on there. Again, they are being multiplied. And if you work this out, you should find that you get 60 combinations. Obviously, again, for listing, 60 is quite a lot. You probably don't want to list 60 possible combinations out. You definitely don't want to be listing the 720 permutations. So that's it for my continuation of combinatorics. My next video will be on powers and roots, but I will also return to combinatorics at some point to do a video on selection, which is where most of combinatorics goes, if you would be interested in that. So if you enjoyed this video, please do like and subscribe. But until next time, keep safe.